Morning again. Morning again. Good morning again. Yeah. So basically, we will be covering now the questions on subnetting 3 C, or basically class C subnetting we will be doing. Okay. So good morning again. So we have suppose this subnet given to us, or the IP address which is given to us, which says that 192.168.4.0 and 24 is there, which means basically that uh, our subnet bits or the network IDs, network bits which we used here are 24. Okay, so this is a class C. So class C means if I just uh, insert again that part of table, which 8 and then 4 updates. So again it's 128, 64, 32, 16, 8, 4, 2, and 1. And then it's basically given as 192. So 192 is basically your 64 plus 128. So it will be 8 bits. Okay. Then 168 is basically your 128 plus 32. I'll just highlight so that you can see which numbers we are using. 128 plus 32 will make 160, and then 8 to make it 168. So it will be basically 1 0 1 0 1, and then remaining are 3 zeros. Okay, then again we have 4 here. 4 here means this 4 is 1, and the remaining bits are your zeros. So it's basically 5 zeros. This is your IP address with respect to the bits, and the last octet is all zeros. 5 4 to 6 7. Okay. Now the question says to you that you have to create some 4 subnets. So we are in the class C domain, and class C means that we have only last octet to play with. So basically, if I have to say with respect to classful subnetting, or in this question it's basically classful only because it's given as 24. So classful means that we have all these 255.255.255.0. Okay, so we have to encroach, or we have to take some bits from the last octets, which can be used as network bits. Okay, so we have to accommodate basically 8 subnets. So 8 subnet means that we have to look at 2 raised to the power, the number which can fit to the condition of n, which can make it basically equals to 8. Okay, clearly for this case we have n equals to 3. So n equals to 3 is there, then we can accommodate 3 hosts from there. So accommodating 3 hosts from there means that I just need to check whether maybe some others are watching other one. We were selecting here, so it's fine. So we are live here. All right. The link will be there. I can see the chats also now, so that's good. So now 2 raised to the power n equals to 8, n equals to 3. So we have to basically use 3 bits from there. So using 3 bits means that obviously it's a class 8, sorry, class 3. These all bits are 1, 255. So this is class full, but we have to do class less now because we have to use 3 bits from there. So it will be 3 bits here. The remaining bits are used for hosts. So basically, the first question asks you that you have to create 8 subnets, and then it says write down the new subnet here. The new subnet mask then will be 255.255.255 and number corresponding to them. Okay, so corresponding to this, numbers are basically this one, right? 64, and these two are also right. So it will be 192 plus 32. So it will be 255 dot 255 dot 255 dot 255. Okay. Now the right we have to find out the number of hosts in one subnet. So number of host bits equals to basically 8 minus 3. So basically we used out of total 8 bits, we used 3 for the network. So number of host bits equals to 3. Basically 5. So number of hosts, if you remember the previous one, it's the rule remains same. Per subnet is equals to 2 raised to the power 5 minus 2, which is equals to 30. Okay, and then the question asks you to write the subnet range. The first one is basically we didn't find out that also, but we will look at that later. So the basic first one is basically, if you see, is your you need to do the AND operation of these. So when you will do the AND operation of these two, it will be equals to this one. When you will do AND operation of these two, the answer will be the top row. Again, if you do the AND operation of these two, the answer will be the top row. And in this case also, because they are all 0, the answer will be the top row. So the first range will be, or the first subnet will be right? And then it says that you have to find the range. So basically, you have to think that what is my block size. So block size is always equals to 256 minus the number corresponding to the last octet, the decimal number of the subnet mask. So it's 224. So it is 224, which is equals to 32. The block size is 32. So the subnets are basically, it will be 32. Then we have 64 because the block size is 32. Then we have 96. Then we have 128. Then 60. Then we have 192. How many we need? Only 8. 1, 2, 3, 4, 5, 6, 7. Okay. This is your basically the subnet ranges. And if the question further asks you what is the possible IP ranges and your broadcast address. So the IP range for the first one, I'll do for first two IP range, basically starting from this one and ending at 30. How many hosts per subnet are possible? 30. So it's from 1 to 30. And the corresponding broadcast is 31. So if you see that there are 32 basically usable address in the range. But the first one we are using for the network over the subnet, and the second we are using for the broadcast here. In a similar way, when you will do the IP and subnet range of this one, it will be your network or subnet address, and then it is 33, and this one goes 63, and this will be 60. So in a similar way, you can do the same calculations for the remaining ones. Okay. So these are the different ways of doing the things. Now, suppose we have this given to us and it asks you all the things which we have done now also. Again, in this case, we have number of network bits equals to 25. So 25 means we have n equals to 1. So number of subnet possible are 2. Okay, so number of hosts per subnet are basically, I'm just doing the same notation I used in the previous one. Okay, so then we have this. So in this case, 25 is given to us. So the number of subnet bits are 1, but number of hosts per subnet is equals to number of host bits. And how many bits are host bits? 7. Why? Because in class C, we have, if I say with respect to class full, then my subnet mask is 255.255.255.0. So we can only play around with the last octet. For the remaining octets, we can't do anything else. Okay, so we just have to keep them as it is, and we can just work on the last octet. So total bits are 8. 1 is used for network. So remaining are 7. So 2 raised to the power 7 minus 2 is basically the hosts per subnet. So it's 128 minus 2 is 126. Now, what is the block size? So block size basically depends upon, let me take this again from here and use it again. So this is basically my, how we got this block size equals to 158. It depends upon this. So how many bits we are using for the purpose of network? One. So this already we, so this is the only bit we are using for the purpose of network. So the corresponding number with respect to this is 128. You see it that way. So it's 128 here, and the remaining bits are 0. So we can say the subnet mask here is 55.255.255.128. Okay, and the first subnet, again, how we will find out the first subnet. We have to first of all 192.168. We use 168. So yes, it was 168, but this is not 10. So 10 is 1 0 0. That is 10. So this is my number of bits corresponding to this one here, and this is my subnet mask. So the first subnet which is we will find out will be by the AND operation between these two bit by bit, or we can say the logical AND operation, which I explained earlier also. So this will turn out to be 192, then it will be 168, and then 10 here, and then 0. So this is your first subnet. Now what is my block size? Is 128. So start adding 128 to it. We have only two subnets here because we are using only 2 bits, sorry, 1 bit for the network. So two subnets are possible. Number of hosts per subnet depends upon this. Sorry, host per subnet depends upon 126. So the first valid IP will be the next number corresponding to this. It's .1. Last valid IP means possible host address is 126, and the broadcast address is 127. So the total are 128. So it's 0, this 1, and 1 to 126. Total are 127, and the last one we used for broadcast. For the second subnet, where the subnet will just end, the second will start. So the network ID or subnet ID is this one, and then we add 1 to it. Then basically that is my first valid IP, and from there till 254 is my last valid IP. So then the broadcast address is 192.168.10.255. Another example, if we use 26 as my CIDR, then in that case we have subnet mask will be again this one, because what we are doing again is, let me copy this part again. That's this one. So we have to now make 192. The remaining things are same. Only difference is 26 bit we are using. So it will be 1 here. So the number of subnets as again will be 2 raised to the power n. We have subnet mask now changed only, which is 255.255.255 addition of these two numbers, which is turned out to be 192 as mentioned above. N equals to 2. So basically we borrowed 2 bits from the host portion from here. Okay, class C, if you remember that 24 bits are for network and the last 8 bits are for host. So number of subnets are 4. The number of hosts per subnet is equals to basically your 2 raised to the power h minus 2. We have 6 host bits. So it will be 2 raised to the power 6 minus 2 is equals to 62. Sorry, 64 minus 2 is 62. And the block size basically is 256 minus the number corresponding to last octet. So it will be 64. Okay. So for a 26 marks mask, we will get 4 subnets, each with 62 hosts. Each subnet has a block size of 64. So 62 hosts are possible. You can say valid IPs are possible. The block size is 64. So where are the two remaining IP address? One is used for subnet and the another one will be used for your broadcast. So and again the first subnet will be the AND operation of these two, logical AND operation bit by bit, and then we have starting number will be 192.168.110.0, 64 block size. The second subnet will be 64 here, third will be 128, fourth will be 192. Okay, now the valid IP addresses with respect to them is add 1 to it and 1 to 62. 62 are possible, and then broadcast will be the last address of the block 63, and in the same way you can find out for the all the substrate. Now this is basically a table which is given to you, and look at this. You will be able to see that suppose we are using 25 there, 26 there. So it's basically the borrowed bit for network portion. So how many bit we are borrowing from here? So it's 25 means 1 means that it's 25 will be CIDR, then 26 CIDR, then suppose we have the CIDR equals to 27, 28, 29 or 30. Depending upon that, the number of host bits. So this table will explain you how that works. So the number of host bits out of 32, because 24 are reserved for class C, will be 25. This one for 6, 5, 4, 3, 2. Okay, binary number corresponding to the last octet will be then 25 is there, so then it will be 1, all 0, 26, first 2 1, then all 0, first 3 1, all 0, 5 zeros, 4 1 4 0, 5 1 3 0, 6 1, 2 zeros. And decimal subnet mask of last octet then will be 128. If one bit is there, here 128. If two bits are there, 192. If three bits are there, adding these three, 224. Four bits are there, adding these four, then it will be 240. 5 bits, 248. 6 bit, it's 252. 7 bits, 254. So that's what's there. So it's there like this. Number of subnets then possible are 2, because we have only 1 bit for subnet. So it's 2, 4, because we have 2 subnet bits, 3, then 8, and so on. And depending upon that, you can easily find out what are the subnet log size of subnet by subtracting the value. So I want you to, I will upload this on the Blackboard, and I want you to try this question from your side. Okay, and then we will have lab session next week, and starting with the queries of you with respect to these questions, and I'm going to upload another set of questions also. Thank you.